The title of our research is a frame rate stabilization scheme for cloud distributed live video processing systems. This is the content of this presentation. First, I would like to explain the introduction of this research. Next, I would like to explain our proposed scheme. Video processing time reduction and how to change video processes. After that, I would like to show some evaluation results. And finally, I will conclude this presentation. We have proposed a cloud-distributed live video distribution system. In this research, we added the frame rate stabilization module so as not to annoy the viewers by unstable frame rate. Introduction. Recently, Internet live broadcasting attracts great attention. One of the services is Ustream. In the Ustream service, the users broadcast videos recorded by cameras on PCs. Another example is tweetcasting. In the tweetcasting, the users broadcast live videos from smartphones. In Internet live broadcasting, the users often add video effects. These are examples. The left figure is a screen of a disaster situation. In this screen, the faces are blurred for privacy preservation. The right one is the screen of a personal live. In this screen, the upload effect is added at interesting scenes. It takes some processing time to add video effects. Therefore, the video effect addition processes cause high computation loads such as face detection, mask image creation, drawing masks, and so on. In the cases that the video processing time is longer than the interval of the video frames, the frame rate decreases, and unstable frame rates annoy the viewers. Therefore, stable, this actually means constant, frame rates are required for Internet live distributions. I would like to mention related work. For video processing time reduction, a scheme to reduce the video processing time by adapting distributed stream processing was proposed. Also, a scheme exploiting cloud services was proposed. However, frame rates fluctuate when the processing time is long, even when the system uses these techniques. Regarding about frame rate stabilization, one of the simple approaches is giving an upper limit on the processing time. If the processing time reaches to the upper limit, the processes are cancelled. This means the faces appear. So that is, these researchers do not consider frame rate stabilization problem on Internet live broadcasting systems. And these are processing servers these are processing servers, and these are viewers. The client here record live videos and send the data to the cloud servers. Here the cloud servers mean the servers provided by cloud services. The cloud servers add video effect to the video data, and the cloud servers send the video data to the viewers. Viewers play live videos. In this assumed system, the frame rate stabilization module in the cloud servers controls the frame rate. First, I will explain how to reduce video processing time. In this research, we focus on hiding the video distributor's face because the most sensitive personal information is their faces. Our idea is that the position of the face does not change largely. For example, the distributor fixes the camera to his room and shoots himself sitting on the front of the camera. Therefore, the face position in the next frame image is close to that in the current frame image. By shrinking the range to detect the face using this idea, we can reduce the video processing time. To determine region to detect the faces, our proposed scheme takes a margin from the position of the face in the current frame image. This red rectangle shows the range to detect the face in the ith frame, and this red rectangle shows the range in the i+1 frame. As shown in this formula, the region to detect the faces is given by taking some margin. As a drawback, the system fails to detect faces if the faces are out of the detection area. Next, I will explain how to change video processes. Our scheme changes the video processes to a simple process when the video processing time is going to exceed the interval of the video frame. Even when the process is changed to a simple one, the video processing time arises. Therefore, our scheme gives a margin time for the simple process. That is, when this inequality is satisfied, our scheme changes the video process to a simple one. I'd like to explain this using an animation. This line shows the time, and this is the time to draw a frame, and this is the next frame time. The deadline here is calculated by subtracting the margin time from the next frame time. When the processing time reaches to the deadline, the system changes the video process to the simple one, like this. Our brief experiment shows that the maximum processing time to blur the full region is 100 milliseconds. So in the experimental situation, the margin time should be longer than 100 milliseconds. This figure shows the flowchart for the frame rate stabilization module. First, the module gets a frame and starts the video processes for the frame image data. While processing the data, the system checks the deadline here. When the process finishes before the deadline, the cloud server sends the processed video data to the output module. Otherwise, if the deadline comes, the system cancels the video process and changes it to a simple one. I will show an example in evaluation result. We evaluated our proposed scheme to check the stabilization of the frame rates. The video process for the evaluation is the process to detect a face and blur the detected image region. When the processing time is long, the process is changed to blur the whole image region. The latter process here is the simpler process. We used OpenCV and the CPU for cloud server is Core i7 and the memory capacity is 8 GB. The margin time for the video processing is 100 milliseconds based on the brief experiment. We measured the time to complete the video processing. This figure shows the result. The horizontal axis is the frame number and the vertical axis is the time to complete video processing. The circle marked line shows the processing time when the frame rate is 1 fps. The triangle marked line shows the processing time when the frame rate is 2 fps and so on. The shorter time than the inverse value of the frame rate means that the system can enable stable frame rate. For example, when the frame rate is 1, 6 frames exceed 1 second. When the frame rate is 4, 19 frames exceed 250 milliseconds. Therefore, we confirmed that a smaller frame rate gives a more stability. The processing time for the simple video process are sometimes longer than the expected time, and some frames exceed the time to start the next frame, even in our proposed scheme. Conclusion: we propose a scheme to stabilize frame rates on cloud-distributed live video processing systems. Our scheme changes the image region for video process and changes the video process when the frame rate is going to fluctuate. Our evaluation revealed that performance for the stability of our proposed scheme. In the future, we will consider multiple upper limits for the processing time, and moreover, we will investigate efficient hiding effects for the frame rate stabilization. Thank you.